Hello, my name is Catalina Sabag, and this is my report for Lab 4, Oscillations. This is a brief overview of what I'm going to be talking about. To begin, the objective of this lab was to investigate the motion of a spring mass system with the mass oscillating in an arc. We used the tracker software to track the observed position and with GlowScript made a computational model to predict the object's motion and energy changes. The goal was to determine whether the model follows the energy principle. The physics principles used in this experiment were Newton's second law, which consists of the net force being equal to dp dt, which equals the mass times the change in velocity over change in time, and that equals to mass times acceleration. We also use the momentum, velocity, and position update formulas. Additionally, we use the energy principle, which states that the change in energy of a system is equal to the work done by the surroundings plus the temperature. We first analyzed the object's position using the tracker's software and obtained the following graphs depicting the position of the object in both the x and y directions. The initial conditions of the experiment were that the mass was 0.402 grams. The initial position was negative 0.112 in the x direction, negative 0.610 in the y direction, and 0 in the z direction meters. And the initial velocity was 0 meters per second. We then used GlowScript and inputted the initial conditions. We also were given that the gravity was 9.8 meters per second squared. And I found that the spring constant was 6.872 and the relaxed length of the spring was 0.123. Then we got that the vector of the length of the spring was the position of the ball minus the position of the spring, and the direction was equal to the length over the magnitude. And then we got the kinetic energy, the gravitational potential energy, the spring potential energy, and the total energy. This is the motion prediction loop. We first calculated the gravitational force, then the spring force, the net force, and applied the momentum principle. Then we calculated the changes in energy. These are the graphs depicting the motion of the object in the x and y directions obtained using the GlowScript code. Some possible errors were that in reality, the system is not isolated from the surroundings, and there will be work done from the surroundings. Another error could be an inaccuracy in the center of mass placement in the tracker software. A question we can ask after completing the experiment is, was the energy principle satisfied? The energy principle was indeed satisfied in this experiment, since no external forces affect the isolated system, so the change in energy must be zero. Even though different types of energy are in the system, the graph shows that the total change in energy is constantly zero. Finally, using the data from Tracker, I compared the oscillation periods in both directions. In the x direction, t was equal to 1.3297 seconds. And I got k by multiplying 4 pi squared times the mass of the object and then dividing it by t squared. And I got that k was equal to 8.98 newtons per meters. In the y direction, I did the same thing and got that t was equal to 1.2347 seconds. And using the same formula for k, I got that k was equal to 10.41 newtons per meters. Thank you.